Hi students, in this lecture I am going to discuss problems based on motion EMF and Faraday's law. Let us see first one. Let's see the question given. A wire of mass m and length L can freely slide on a pair of parallel smooth horizontal rails placed in a vertical magnetic field as shown. The rails are connected by a capacitor of capacitance C. The electric resistance of the rails and the wire is 0. If a constant force F acts on the wire, as shown in the figure, find the acceleration of the wire, right? This is a question given. Let us see how to find acceleration of the wire. So first of all, draw the given circuit. So it is given a capacitor. It is a capacitor. So now there is a wire which can slide on the rails. There is a wire which can slide on that. Applying on this a constant force F. Okay, and a capacitance given C, and this length that is given as L. So its length is L, mass M, field is now into the board. Right, cross check, mass M, length L, capacitance C, applying a constant force. Now you can see we have to find acceleration of the wire. So we are knowing that acceleration equal to net force by mass. Okay. So first focus what is net force. So coming to here, because of this force, the wire slides right side. That means area of this loop. So this part of the area is now increasing because of motion of this wire. Because of that increasing area, flux increases. So according to Lenz's law, direction of induced current, it is in such a way that it opposes cause of its production. That means since the field is now into the bore and the flux is increasing, direction of current is in such a way that field due to that induced current must be, it is outwards. Okay, that means outwards means the current it must be anti-clockwise. So first we have to decide direction of current. It is anti-clockwise. So that because of this anti-clockwise current, field will be outwards. Right? Now focus carefully. If you take now this board plane as XY plane, it is XY plane, then current in this wire will be along positive y-axis. Okay. Then first of all, focus direction of the magnetic force. Magnetic force, that is I into L bar cross B bar. Because if you know this magnetic force, then we can get net force. From that, we can calculate what is acceleration, right? So this is I into L into B. Okay. Focus now direction part. L bar cross B bar. Direction of L bar is direction of current. Current is now, it is a J cap direction part. And coming to the field, it is minus K cap. See what we get? J cap cross minus K cap. J cap cross K cap, I cap. This is minus I cap. That means this magnetic force, it is now left side. Okay. That means now net force equal to applied force minus magnetic force. Okay. Direction is minus IK. Let us focus that modulus value how much? Coming to I. See, we are given here capacitor. Let us take at one instant charge on the plates of capacitor is Q. Okay. If charge is Q, then I can say current equal to dq by dt, right? And we are knowing that charge equal to C into V, right? Q equal to CV. So C into E value. It is now EMF induced across the ends of this moving rod or moving wire. Okay. And that EMF equal to, already we have learned, a motional EMF equal to PLV, because field is into the board and velocity normal to rod length. That means L bar, B bar, and V bar. All these three vectors are mutually perpendicular. That's why it is BLV. Okay. It is actually L bar dot V bar cross B bar. Right. So this is now C into, so Q equal to CV. That is now BLV. Now see what we get. Take constants outside. CBL constants. CBL taking outside. Derivative of velocity. That gives acceleration. Right? Therefore, magnetic force. Magnetic force is equal to I into L into B. So this becomes now B square L square C A. That is magnetic force. Now see net force. Net force equal to F minus FB. This net force equal to mass into acceleration, right? Now F equal to MA plus this value. So A into M plus remaining part B square L square C. Okay. So from this we can say acceleration is, it is a constant, right? Because in this all values are constant. So B square L square C. Okay. That means here we can expect all questions basing on kinematics because acceleration is a constant. So we can use all equations like V equal to U plus Ct, S equal to Ut plus half T square. Like this, all those equations we can use because A value constant, right? Okay, let us see the next problem. See what is given. Figure shows a metallic square frame of edge A in a vertical plane. A uniform magnetic field B exists in the space in a direction perpendicular to the plane of the figure. Two boys pull the opposite corners of the square to deform it into a rhombus. They start pulling the corners at t equal to 0 and displace the corners at a uniform speed u. The first one, find the induced EMF in the frame at the instant when the angles at these corners reduce to 60. Next, induced current. Next, total charge. By the time it deforms into a straight line, right? Let us see how to start. So first we have to focus on, okay, first of all, see the diagram given. It is a square. So it is a square. Now pulling the corners like this with a constant speed. So if you want to find current, first of all, we have to focus. The first one is asking EMF induced, right? So we have learned that EMF induced, it is equal to minus d phi p by dt, negative of rate of change of magnetic flux, right? Let us see how to calculate. In this, you can see field is now normal to this board plane, which is uniform, or you can say which is a constant. But coming to area of this loop, it is a change. So here flux is changing because of change in area of the loop. Okay, that means this is equal to minus V into dA by dt, rate of change of that area. Okay, let us see how to calculate now. First of all, find out area of the loop. So condition given that one angle at these corners becomes 60, right? So let me take this is theta. Then this also theta. Okay. So first I am finding area of this loop in terms of theta. Okay. Let us see that. You are given side length is here. You can see this is now having four triangles. So area of these four triangles gives us area of this loop. Okay. See here what I am writing. A equal to 4 into half base height. So I can say base is now a cos theta, height is a sin theta, half base height. See carefully once. I have taken this as base, okay, and this as a height. So half base height into 4, right? This is now area. So this is equal to here 2 times. It is a square sine 2 theta. Use that here minus b into a square 2 cos 2 theta into d theta by dt, right? Cross check once. We got area a square into sine 2 theta, cos 2 here 2 times. So it is now 2 sine theta cos theta, that is sine 2 theta. So it is now a square, derivative of sine 2 theta, 2 cos 2 theta into d theta by dt. Now in this, if we know d theta by dt, then we come to know what is E value, right? Now to find that, to find d theta by dt value, let us use now the given condition. That is, these corners are pulled with a constant speed u. Okay, let us see how to use that. So here I am taking the center of the square as origin, and that point is fixed, that is not changing. With respect to that, for this corner, we can see position coordinate. If I am taking this as x-axis, for this corner, position coordinate is x equal to, it is a cos theta, right? I have taken this line as x-axis and this is origin. For this point, this is now position coordinate. Now differentiate this dx by dt, which is equal to u, right? That is now a into derivative of cos. It is minus sine theta into d theta by dt. Now use this result in this way. Then see what we get. E equal to minus is here and we have minus here. Gets cancelled, becomes a plus. Remaining is, see what is it? We are having a 2ba square cos 2 theta. Already minus cancel. Remaining is now u by it is a sine theta. Right? This is the final answer. Now in this take, given At the instant, angle becomes 60 at these corners. That means theta equal to 30, right? Theta equal to 30. So 2 theta 60. So cos 60 1 by 2, sin 30 1 by 2. So these two cancelled. A square and this is A. Remaining is now 2BAU. That is now EMF induced. Okay, right. Next, you can see asking induced current in the frame at this instant. At that instant current, I equal to E by R. E value is known, R value given, right? Next. Next, he's asking find the total charge which flows through a side of the frame by the time the square is deformed into a straight line. Okay, let us see how to calculate. If you want to find out the charge, so we know current equal to dq by dt. Then dq equal to I into dt, right? So dq is equal to E by R into dt. In the place of E, I am writing here modulus value. It is simply d phi by dt into 1 by R into dt, right? I am taking the place of E. I have taken just modulus d phi by dt 1 by R into dt. Now integrate this. Then charge equal to, see what we get, dt over. Remaining is now integration of d phi upon R. R is a constant, take outside 1 by R. Remaining is now integration of d phi. That becomes delta phi. Like initial value phi 1, final value phi 2. This is now phi 2 minus phi 1. Okay. Now you can see here. He's asking by the time the square is deformed into straight line. When this becomes a straight line, area becomes 0. Okay. And initial area is square. Therefore, this is equal to 1 by R. Initial area P A square. Final area 0. So change in flux upon resistance, that gives charge. Okay. And here we can conclude one more thing, that is, this charge is not depending on how fast flux is changing. Okay. It is simply depending on what is the change in flux and resistance. But if you focus how fast flux is changing, right, it depends on that. But charge is not depending on how fast flux is changing. Okay. Let us see the next problem. Right, see the question given. A rectangular frame of wire ABCD has dimensions 32 by 8 and a total resistance of 2 ohm. It is pulled out of a magnetic field by applying a force as shown. It is found that the frame moves with a constant speed. Find this constant speed, the EMF induced in the loop, the potential difference between the points A and B, the potential difference between the points C and D. Okay, let us see how to start. Condition is given that frame moves with a constant speed. So constant speed means net force must be equal to 0. Let us make the given diagram. So it is given A, B, C, D. CD is out of the field. Just field is up to here. I'm just drawing here one dotted line, field up to here, applying a constant force F. Sorry, applying a force F, velocity given constant. So first condition, find this constant speed, next EMF induced, next potential difference. Okay. So first of all, focus how to calculate EMF induced. So again, take now Faraday's law, or directly we can use motional EMF. Okay. So we have motional EMF is equal to L bar dot V bar cross V bar, right? You can see CD, it is not in the field. So across CD, there is no EMF induced, okay, in CD. Next, coming to BC, or if you take AD, velocity parallel to these sides, BC and AD. And we are knowing that out of these three vectors, if any two vectors are parallel, no EMF is induced. That means I am writing here EMF induced across CD 0, across BC also 0, across AD also 0, right? Now EMF is induced only across AB, okay? And you can see here field is now into the board, velocity normal to length, therefore L bar, V bar, V bar, all three are mutually perpendicular. So directly I can write B, L, V, right? Now substitute values here. Values given at B is given. So what is B given here? It is a 2 10 power minus 2, right? 2 10 power minus 2 B. And next L value. L is given how much? Side length, right? AB length. AB length is now, it is 8 10 power minus 2, converting into meter. Coming to velocity. Velocity is not known because that we have to get it and see how to get it. Condition given constant velocity. Constant velocity means force acting on AB must be left side. This is magnetic force. If this magnetic force is able to balance this applied force, then velocity constant, right? And that force is, see how much? That magnetic force is equal to, you can see I into L bar cross B bar. So here between L bar and B bar angle is 90. So modulus value, it is ILB. And what is I value? I value is now E by R. R value given, right? See how much R value given? Resistance. Total value given 2 ohm, right? So E by R into L into B. So E value BLV. So it becomes B square L square V upon R. So if this is equal to F, okay. So already F is given. So in this, except to be remaining all values are known. So now what we can do is equate that applied force to magnetic force. Okay. So from this, we are going to get the value of P and see how much we are going to get. And that value comes out to be 25 meter per second. Okay. Equating this applied force to the magnetic force. Since we know V value, substitute that here. Then we get EMF. See that value comes how much? That value will be 4 10 power minus 2 volt. This is EMF induced. Okay. Now you should be very careful while calculating potential difference. See, we are knowing the difference between EMF and potential difference. right? While learning current electricity, in that we have seen for a battery EMF, right? So here, coming to the question, see the question given constant speed, we got 25 meter per second. EMF induced in the loop, that is 4 10 power minus 2 volt. Now here, the next one, potential difference between the points A and B. Potential difference between the points A and B. Okay. Now see what I can write. We can replace now AB with a battery. We can replace AB with a battery. Then potential difference equal to it is EMF minus I into its resistance. Okay. I am replacing this AB with a battery whose EMF equal to A, right? And current. Can you guess here direction of current? See once, pulling the loop out of the field. So flux in this area, it will decrease because area in the field is decreasing because of that flux decreasing, right? Then according to Lenz's law, direction of induced current is in such a that it tries to oppose the cause of its production. That means due to induced current, magnetic field direction must be, it is inwards, right? Because since flux is decreasing, it tries to oppose. So trying to oppose means it tries to increase it. So increasing means that field must be along the existing field. Okay. So keeping thumb inwards, curl fingers of right hand. Right. See once keeping the thumb inwards, curl fingers of right hand. Then it will be clockwise. Current is now clockwise. Right. Like this. Okay. So if you are replacing now with this AB with a battery, we have to show like this. Getting it? And the current is now passing like this. That means now battery is discharging, right? So when it is discharging, it is EMF minus I into R. I hope you got the clarity. Now focus calculation part. That potential difference equal to EMF. See EMF, how much we got? Is a 4 10 power minus 2, right? So first calculate what is I into R. Okay. So I'm making calculation here. I into R, that is equal to I value. See how much we get. I value. EMF is we got 4 10 power minus 2. 4 10 power minus 2 upon resistance. Resistance how much? 2. For complete one. Okay. I resistance. Now you should be very careful here. We should take resistance of AB. Okay. Resistance of AB. So we are given total resistance is how much? Total value 2. Total value 2. I am dividing that with length of the loop. That this is 32. This is 8. So this is a 40. This also 40. Total value, it is 8. So 2 by 80. Resistance per unit length into length of this wire AB. That is now 8. Okay. Then see this value comes out to be how much? It is a 4 10 power minus 3 volt, right? Because 2 gets cancelled, 8 here 10 times, right? 4 10 power minus 3. That means potential difference equal to, this is a 4 10 power minus 2 minus, this I am writing as 0.4 10 power minus 2. Okay. So this is equal to 3.6 10 power minus 2. That is now potential difference. Okay. Across AB. Next, see what he's asking. Across AB potential difference. Now he's asking potential difference between CD also. Between CD. We can see across CD, no EMF is induced. And we have potential difference because of the current flow. So current is now that we got, right? This is a current into resistance. For CD also, same resistance, right? That means potential difference across a CD, that is equal to I into R. So this also how much? So this value how much? 4 × 10⁻³ volt, right? So in the same way, we can calculate potential difference across BC, potential difference across AD because of the current flow due to resistance of the wire, right? So I hope you got clarity.